Alright, so in our last video we did two examples using Newton's method. Now those examples had us using the recursive formula we came up with to get to a certain value, our zeros for the function. If we continue to get closer and closer to a single number, we say that that converges. In fact, it's like finding the limit. I did say in the last video we're going to look at an example where this doesn't work, this Newton's method. So example 3, spoiler, Newton's method isn't going to work. We're going to look at the function f of x equals x to the 1/3, so the cube root of x. But something we know is it's not differentiable, at least at x equals 0. And we can show that by finding the derivative and setting it equal to 0. Or even just putting 0 in for x. We'd see it doesn't work. It's going to give us a denominator of 0. So, let's figure out why this doesn't work. In fact, we're going to show, to see why it doesn't work, that it fails Newton's method fails at an initial guess of 0.1 at 1/10. So, let's look. What we know we need to do is we need to find f prime. So to do that we bring our 1/3 down. We have our x, we reduce the power by 1, so that's going to be negative 2/3. Okay, so now we're going to take our formula, our recursive formula, xn plus 1 equals xn minus f of xn. So we're going to have xn to the 1/3 over 1/3 times xn to the negative 2/3. Now we can clean this up a bit. When we're dividing by a fraction, like we are with this 1/3, we can multiply by its reciprocal. So we can rewrite this expression as xn equals 3 xn to the 1/3 over xn to the negative 2/3. We also know when we are dividing things, dividing exponents with the same base, we can subtract the powers. So we can again rewrite this as xn minus 3 xn to the 1/3 minus negative 2/3. And when we minus negative 2/3 from 1/3, that gives us 1. So we're going to have xn, so xn plus 1 equals xn minus 3xn, which we can simplify to just make 2xn. In fact, not 2, negative 2, because 1 minus 3 is negative 2. So that doesn't work, or we can see once we start plugging in our x1. So if we want to find x2, we're going to take and put x1 into the formula we just made. So that's going to make negative 2 times 0.1, which is going to be negative 0.2, which already goes to a different end of the graph. We want to keep going positive and try to get closer to 0. So let's look at the next one, x3. That's going to take negative 2 and multiply it by negative 0.2, which is going to give us 0.4. And if we find x4, negative 2 times negative 0, not negative, just 0.4, is going to give us negative 0.8. And if we kept going, found x5, we're going to go negative 2 times negative 0.8. That's going to give us 1.6. Because we alternate between negatives and positives here, we're not going to converge on one point. So that alone is enough to say that in this case, Newton's method is not going to work to find our 0 of this function. And we're going to leave it at that. We're done talking about Newton's method.